Hello, it's Dr. Gibson. Welcome to our Module 5 video, Correlation and Prediction, otherwise known as regression. All right, our highlights this time, or our main points, if you will. Correlation, linear versus nonlinear, right? Correlation and causation, linear prediction, z-scores versus regression, significant correlation, and then looking back at last week's ANOVA test. Okay, correlation, linear versus nonlinear. So two variables are correlated if there is a relationship, pretty much any kind of relationship, really. There are correlations that are nonlinear. The Aaron text describes these as curvilinear. However, most of the time when you see the word correlation, what is meant is linear correlation. Here in this class, we are only interested in linear correlation. In the test, we are using only tests for linear correlation. So correlation and causation. If changes in one variable's value cause changes in another variable's value, the variables will be correlated. In other words, if there is causation, there will be correlation. However, in the other direction, it doesn't work. If two variables are correlated, it does not mean that changes in one variable's values cause changes in another variable's values. Put simply, correlation does not imply causation. There are many things that can lead to correlation other than changes in one variable causing changes in the other. All right? Linear prediction. So now we're getting into kind of a conversation about regression here. Z-scores versus regression. The Aaron text uses z-scores as a method of prediction. This method does work well for single values of variable, all right? However, the z-score method is rarely used because it does not produce an equation that describes the relationship between the variables. Regression is by far the most commonly used method for prediction, and it does produce an equation that describes the relationship. Later, week 6, next week, we will perform a linear regression. This week, we're doing a linear correlation. All right, so a linear correlation is said to be significant when the data values follow a line closely enough to reject the hypothesis that they don't follow a line. Another way to put this, a linear correlation is said to be significant when the linear relationship, as measured by the correlation coefficient, is strong enough to reject the hypothesis that there is no linear relationship, right? So these two are pretty much the same thing. It's just the first one is in terms of the graph. The second was in terms of the correlation coefficient. All right, so let's look back at last week's ANOVA test. Let's start by looking closely at the null hypothesis to see what it does and does not say. The null hypothesis here says, we're talking about the ANOVA, remember, there is no significant difference between the average maintenance costs of the 5 hiking trails maintained by the Municipal Forest Service. So the null hypothesis is saying there's no significant difference anywhere between any of the 5. It's not saying, do you see what I'm saying? If there's a single significant difference between any 2 of the 5, that's going to force the rejection of the null. Right? The null is saying there's no significant difference anywhere among any of them. All right. The descriptive statistics table shows means and standard deviations for all 5 groups. The fact that we have more groups makes for a more complicated situation. All right, the eyeball test won't tell us as much as the t-tests. Well, let's go look at the descriptive statistics table. That's down here. There it is. So it lists all 5 of our trails. All right. If we come down here and look at the means, this first mean is 19.83, and then we get 9.67, 7.67, 5.33, then back up to 14. So what you can see, just kind of eyeballing it, is that the 2 biggest ones, the first one, the last one, are maybe kind of close together, but then there's maybe a gap down to the other three, which are closer together. All right. So, and really, this top one here, this Eaton Canyon, is quite a ways from the three lower ones. Okay. So how does it turn out? Well, though it turns out at the end, in fact, is the only significant difference is, well, there's kind of three of them, if you will, between Eaton Canyon and each of the lower three here. They're in the middle. There's no significant difference between Eaton Canyon and the next biggest one, Milliard. There's no significant difference between Milliard and any of the other three, right? So you can kind of get a sense for more or less what might be coming just by looking at the means. Now, it's not going to tell you exactly what's coming, but it's going to give you a sense of the possibilities. All right? The ultimate result that Milliard Canyon's costs are significantly different from those of the three lowest trails, fits with what the eyeball test showed us. There were no other significant differences. All right? Now it's your turn to perform a linear correlation. All right, that's it for this week. I'll see you next week.